Welcome to the Hidden Layer, where we decode the latest in AI and show you how to apply it.
What if you could eliminate 95% of the waste in your AI agent's brain? No, that is not a typo. 95%.
Today, we're going to decode a new paper that fixes a hidden tax that's making AI agents expensive, slow, and honestly pretty unreliable. This is a huge deal for anyone building with AI. And hey, stick around because later I'm going to share a simple, kind of brilliant trick from this paper that'll make your own agents way more verifiable and trustworthy. All right, so let's get into it. The problem has a name, the tools tax. And it all comes down to a fundamental flaw in how AI agents talk to external tools through something called the Model Context Protocol, or MCP.
Okay, picture this. Imagine having to read the entire user manual for your phone, your microwave, and your car every single time you wanted to send a text. That is literally what's happening here. The protocol is stateless, which is just a fancy way of saying it has no memory. So on every single conversational turn, the agent resends the entire instruction manual, the schema, for every tool it has, burning through tens of thousands of valuable tokens.
And look, this isn't just about money. It's so much worse than that. This tax creates these three cascading failures that just absolutely cripple your agent's performance. First, the economic failure. It's just massively inflating your API bills. No surprise there. Second, the cognitive failure. This is a big one. When the agent's brain, its context window, gets clogged up with all this repetitive junk, its ability to actually reason just collapses. And third, and this is scary, it's a security failure. It opens the door for bad actors to hijack your agent by injecting malicious tool definitions, a vulnerability known as tool poisoning. Now, this is where it gets kind of insane. Just look at the sheer scale of this waste. And these aren't just made-up numbers, right? The paper cites real-world audits. A pretty typical setup is already burning up to 20,000 tokens per turn. But look at a full GitHub or an enterprise database integration. We're talking over 50,000 tokens being wasted every single time you ask it a question. It's wild. And this chart, it just perfectly illustrates that cognitive failure we were talking about. In a typical long conversation, over 3/4 of the agent's brain is just filled with junk, repeated tool manuals. That leaves this tiny little sliver for the actual conversation, for your instructions, for critical thinking. It's no wonder they start to drift and make mistakes, right? So the big question is, how do we fix this massive systemic problem? Well, the paper proposes this beautifully elegant solution. It's called tool attention. The core idea is just so smart. It's about stopping this force feeding of every tool manual on every single turn. Instead, tool attention acts like a smart gatekeeper. It lets the model dynamically pick only the tools that are actually relevant to what you just asked. It's about being precise and efficient, not lazy and wasteful. Okay, so let's get into the mechanics. How does this actually build a smarter agent? It's a really clever middleware solution, and it works in 3 core steps. Okay, so first, it uses AI to figure out what you're trying to do, and it ranks all the tools based on how relevant they are. Think of it like a super fast, super smart search engine. Second, it acts like a security guard. It checks if the agent even has permission to use a tool right now. And then third, and only after a tool passes both of those checks, does it lazy load the full, heavy instruction manual into the prompt. And the difference is just night and day. On the left, you've got the old way, this fire hose of junk just flooding the agent's brain. And then on the right, with tool attention, you get this clean, focused, totally relevant toolkit, perfectly tailored for the specific job at hand. So, the million-dollar question. Does it actually work? This is where it gets really exciting. The results from the paper's simulation are, well, they're absolutely dramatic. First off, just look at the token reduction. So in a simulation with 120 tools, tool attention just slashes the tokens spent on those tools from over 47,000 down to under 2,400 per turn. There it is. That's the 95% reduction we started with. That is a total game changer for your costs and your speed. And that incredible efficiency, it translates directly into better performance. The paper projects that task success jumps from around 72% all the way up to 94%. That is a massive leap, over 20 percentage points. And why? Well, it's simple. The model has a clean, uncluttered workspace to actually think and reason properly. Okay, now for that bonus tip I promised you at the beginning. This is how engineers can use this to build way more reliable and verifiable AI agents. Seriously, this is the secret sauce.
It's called a hallucination rejection gate. And it is a brilliant safety net. See, since tool attention has already decided which tools are valid for this specific turn, this gate acts as a final checkpoint. So if the model hallucinates and tries to call some random tool it wasn't given, bam! The gate catches it, blocks the call, and forces the model to go back and use only the valid available options. It's so cool.
So, for any engineers out there building agents, these are your key takeaways. This is a drop-in solution, right? You don't need to retrain or change your model at all. It makes your agent dramatically cheaper, faster, and smarter. It makes it way safer by shrinking that attack surface. And, maybe most importantly, that rejection gate gives you deterministic control. It makes your agent's behavior predictable and verifiable. That's huge.
And this all leaves us with a really powerful question. If we can reclaim 95% of an AI's wasted brain power just by being smarter about protocols, what other hidden inefficiencies are holding AI back? It kind of suggests the real frontier isn't just about bigger models, but smarter protocols. Thanks for tuning into The Hidden Layer.